Okay, let's do a quick mic check. I think the mic is working. Hello everybody, and welcome back to another AI Squads with my tutor. This is day 6 of the squads, which is, it feels insane. I feel like we're already halfway through the course, and yeah, it feels like I've just started. But yeah, we've got some really exciting stuff up today. We're covering 2 different things. We're covering what happens when AI messes up and why that might be your fault. And we're also going to be looking at a new topic today of machine learning. So yeah, really fun, exciting stuff. So stick around for that. And as always, we'll be starting at 5 past so that everyone who wants to come along can come along. So sit tight, grab yourself a drink. I've got myself some tea in this cute little mug here. And yeah, we will start at 5 past. If you have joined us or have never been here before, please write a message in the chat just saying hi so I know you're there. Maybe tell me something about your day, something you've been up to. And then, yeah, we'll get this started. Hi there. So yeah, like I said before, if you're just joining us, if you wouldn't mind saying a quick hi in the chat so I know you're there, and then yeah, at 5 past, as always, we will get started. This one is gonna be, should be quite relaxing. It's not as, I'd say, heavy as the other ones are, as the other ones have been throughout the past few sessions, because we are covering something brand new, which should be quite interesting. So yeah, it should be good. Also, hopefully a lot of this stuff should be quite new to a lot of people. I don't think this is something that a lot of people will cover in like GCSE or even A-level. But these are techniques and things that you could use in your computer science projects at school, for example. So anyone here taking computer science, this should be very useful for. Yeah, like I said, we will be starting in 2 minutes, so we'll just wait for that. And if you're just joining us, say a quick hi in the chat, tell me how you are, tell me how your day's been, and yeah, we'll get started. Just to let you all know, we are starting in just a minute. So those of you who are here, hold tight, you've only got a minute to wait. Okay, that is 5 past, so we'll get this show on the road, and then anyone who joins us, we will catch them up. So, I think you all can see my screen on the board there. But yeah, hi everyone, welcome back to AI Squads. So, like I said at the start of this, we are looking at two different problems today. We are looking at why AI mess up and the importance of data quantity and quality. But we will also introduce a new topic today of machine learning. So, today will be our last look at machine learning for kids. Which is a website we've been using for the past 5 weeks now. And from this point on, we'll be using different websites to look at different machine learning techniques, one of which is Google Colab. So let's first have a look at when AI messes up. So this is a thing I've noticed in the comments a lot of these videos. A lot of people are struggling with a lot of AI models, and they'll say something like, my AI can't tell the difference between this and that, or my AI doesn't work. And a lot of the time, it's to do with the quality or quantity of data that you're giving it. To kind of show you what I mean, I'm going to do a quick demonstration called red apples and green tomatoes. I'm going to quickly just bring the screen back to me, and then I'll show you what I mean. Alrighty, so this website should be very familiar to all of you. This is machine learning for kids, and I've created this quick project here to try and calculate the difference between an apple and a tomato. I wanted to recognize an apple or a tomato. Now, can anyone recognize what might be wrong or might go wrong with our current data set? Anyone got any ideas? If you've got any ideas what might look a little bit wrong, a little bit different with our data set, let me know in the chat. If you don't know or you don't think there's anything wrong with it, just type no in the chat. Some of you might think it's perfect. Okay, I guess we're all feeling shy today, that's fine. So what hopefully a lot of you should realize having a look at this data set is that all the apples in the data set are of one color, green, and all of the tomatoes in the data set are of one color, red. I'm sure you can probably imagine that this won't go very well when trying to test it with new data, and I'll show you what I mean. So once I've trained up this project and try and do something with it, I now want to test it with a bunch of images. So I've got this test data set here. I wonder if I can show you it. Here it is, yeah. So a bunch of tomatoes and a bunch of apples in my test data set of all different colors. And if I run the test data set on my machine learning algorithm, let's see how many it gets right or wrong. So as you can see, it can get tomatoes quite right, but it also thinks that apples are tomatoes. It cannot tell the difference at all between a tomato and an apple. And in fact, every single item on that test data set, it thinks is an apple. So what's going on here? What seems to be happening? Well, when you train a machine learning model, you're asking the computer to look at these photos for patterns. So it looks for what each of the photos in those sets have in common. So this could be the color, this could also be the different shapes, and you might want it to recognize between apples and tomatoes, but the computer doesn't know that. It could spot patterns about the color of the background, or whether the photo is blurry or it's focused, or the lighting is dark or it's bright, or the object is large or small, or many other things. So when it makes these pattern decisions let me say that again. When it makes decisions based on recognizing patterns in these new photos, it can sometimes get the wrong answer. So as you can see here, it's getting confused. So what can you do to help it do better? Well, you can add more to your model. If you add a wider variety of photos, for example, you add in both red and green apples, or you add in some photos with apples with a leaf, tomatoes with a leaf, some without, you're more likely to have a better machine learning model. And that is a very important thing to remember going forward when you create your machine learning models, is to remember what you're feeding it, what is the data that you're giving it, and how good is that data, both in how much data do you have, but also how varied is your data. So I think that should answer the question that a lot of you were having with, why isn't my thing working? 99% of the time, it will most likely be with your data. So make sure you've got, like I said, quantity and quality. I'm just gonna take a quick break here, and do you guys have any questions? If you don't, that's fine. I will move on. Okay, it seems like no one's got any questions, so we are leaving machine learning for kids behind to answer our next question, and that is, what is machine learning? So here's a diagram of what the terms of artificial intelligence, machine learning, and deep learning means. Currently, we've only looked at the top one, artificial intelligence, but we are going to move on to machine learning, which is actually a subset of AI. So the way that machine learning works is it applies statistical methodologies to identify patterns and then make decisions. So the main thing that you need to know when it comes to machine learning are that these computers that we're teaching, they're not sentient. They cannot think and they cannot process the world independently, unlike ourselves. They need us. Therefore, to get them to think and process inputs, we can teach them. So how do we do that? Well, there are three main stages. First one should be quite obvious. We've covered this quite extensively, and that is collecting the data. So as you know, machines initially learn from the data that you give them, and as I've just said, it is of the utmost importance to collect reliable data so that your machine learning model can find the right pattern. The quality of your data that you feed to the machine will determine how accurate your model is. The next part is the algorithm. So this is both choosing and using an algorithm. So a machine learning model determines the output you get after running a machine learning algorithm on the collected data. It is important that you choose a model which is relevant to whatever task that you're doing. And then finally, it will make a prediction based on the data and the algorithm it's given. So all these steps you've seen before. The difference is the algorithm part. We haven't really covered this in great length at all. So I think it's important to ask ourselves, well, what's an algorithm? So an algorithm is simply just a set of instructions that a computer or a person can use to complete a task. Think of it like a recipe for a cake. So the recipe tells you what ingredients you need, how to mix them together, how long to bake the cake for, all these kinds of things. Just like a recipe for a cake, an algorithm can help a computer solve a problem or complete a task. Algorithms can be really, really simple, like adding two numbers together, or it can be really complex, like processing a huge amount of data to make a prediction. No matter how simple or complex the algorithm is, it always consists of a set of instructions that the computer follows to complete a task. It is also important to remember that you can use different algorithms to solve the same problem. I don't know if you've ever been in maths, but when you... Hang on, I had a point there. I'll come back to that. So, where was I? Machine learning algorithms. So let's have a look at some of the different machine learning algorithms that we could cut over the next few sessions. So we are going to look at decision trees, nearest neighbor algorithms, probabilistic algorithms, and maybe a few other ones as well if we have time. So starting with decision trees. So a decision tree is a way of making decisions by breaking them down into smaller and smaller pieces, kind of like a tree with lots of different branches. So you should notice on this diagram how it works. The top part is one of the leaves or nodes, and the arrows represent the branches. So an example would be like, imagine what you decide to wear today in the morning. You might start with a big question like, what do I wear? And then you might break it down into smaller questions like, is it hot outside, or do I have to go to a fancy event? So each question will lead to more questions until you finally arrive at a decision about what to wear. A decision tree works in much of the same way. Starts with a big question or a problem, and then it breaks it down into smaller and smaller and smaller pieces until it arrives at a solution or another decision. Each branch of the tree represents a different option or possibility, and each decision point leads to more branches and more possibilities. I see someone in the chat has said hello. Hello, Zul. Welcome. An example I've put on the board of a decision tree is a decision tree to try and find out about animals. So it starts with a big question, does it have feathers? And then it breaks that down even further to, can it fly? Does it have fins? And then it tries to decide whether or not what you're looking at is a hawk, a penguin, a dolphin, or a bear. This is probably one of the most simple algorithms you could use. But before I move on, does anyone have any questions about what we've covered, or any questions in general? Yeah, I'll just take a quick break. Hopefully this is all making sense so far. Official Spoon says, yeah. Okay, cool. I'm glad this all seems to make sense. If you guys have any questions at all, or want to ask me anything, or stop me at any time, feel free to. So another one of the algorithms that we are going to cover over the next few sessions is something called KNearest Neighbor algorithm. Sounds scary, but it's really not. So this algorithm works a bit like the game of which one is not like the others. So imagine you have a bunch of pictures which are of animals, some of which are dogs and some of which are cats. You want to tell the computer the difference between the two. The KNearest algorithm works by looking at each of the features of the picture, so like the shape of the ears, the colour of the fur, the size of the animal, all the different types of features of the animal that you could think of. Then, when the computer is given a new picture, it looks at the features of the picture and then compares them to the features of all the pictures it's seen before. It then finds the K, which is just a number, of pictures it's most similar to the new picture, and then it looks at what kind of animal those pictures are of. If most of them are cats, then the computer can guess that the new picture is of a cat. If most of the pictures are of dogs, then it can guess that the new picture is of a dog. Does that make sense? I think I spoke that one a little bit too quickly, but If it does make sense to you, just type yes or yeah in the chat, and then we will move on. I have a question for everyone who's currently watching. Has anyone ever tried to use any kind of machine learning algorithm before? If you have, let me know, and if not, just type no into the chat. I'm just curious to see if anyone's ever covered something like this before. Okay. I guess no one's ever covered any kind of machine learning algorithms before. That's fine. We will cover these all in a lot more, not necessarily detail, but a lot, just a lot more examples, so you know how to use them better. Let's move on then. Oh yes, okay. The cheese sandwich demo. I wasn't sure if I was going to do this. We'll see how this goes. We'll see if yeah. So to better understand how an algorithm works, the best example I've seen, and I've tried this with a lot of people, is the cheese sandwich demo. So imagine you meet a robot whose job it is to make cheese sandwiches. How would you tell it to make cheese sandwiches? And how many steps would you need to make cheese sandwiches? Normally, I would ask people to say out all the different steps or count how many steps they think they need to make a cheese sandwich, but it seems like not everyone's in the mood to chat today, which is fair enough. So basically, the point of this is meant to teach you that people could take maybe 3 steps to make a cheese sandwich, and sometimes people might take 10,000 steps to make a sandwich. It's also interesting to consider that some people might have thought of different things that other people may not have thought of. For example, some people talk about you might need to get a knife to cut the bread, or you might need to go and buy the bread from the store if you don't have it, or you might need a chopping board, and some people don't consider that. So you might need a plate, for example. So what this is meant to teach you is that everyone can solve the problem, but people might have different ways of solving the problem. And that's why we have different algorithms. A lot of the times they can still get to the same solution while doing solving it in a different way. And just to show you what a robot would actually think, I also asked ChatGPT this morning how it would make a cheese sandwich, and it came up with 10 steps on how to make one. To get a better understanding of algorithms, I recommend you check out this website, which I'm going to demo to you now. It's very similar to Scratch, but it should help you understand how the process of an algorithm works, and also how that you can get to the same solution while using different steps. It's called Blocky Maze. I'll show you. And I'll also put it on the chat if anyone's interested. So this is the game. As you can see, it's very, very much like Scratch. You basically build an algorithm like so, and then you run the program. Ta-da! It should be very straightforward on how to use it, but what it should teach you is that there are 1,000 ways to solve a problem, but how you do it is up to you. I will also link this game in the chat for those of you who never really heard of an algorithm before and would like to try it out for yourselves. Okay, does anyone have any questions about anything that we've talked about in this episode before I move on? Okay, so yeah, Inga's just said in the chat that something I should have mentioned at the start. There is also a feedback on this session. Basically, if you could fill out a quick form, it only takes a couple minutes, and it just gives us feedback on these tutor sessions, whether you enjoy it, whether you don't enjoy it, anything we can improve, stuff like that. Inga has put the link in the chat if you mind clicking it. And yeah, okay, so it seems like no one's got any questions. So we've got about 3 minutes left before this end of the session, so I'll quickly wrap up what we have done today and also explain what we're going to cover next week. So today we have looked at 2 different problems. The first one is we've looked at how our machine learning models, how our artificial intelligence might mess up. And spoiler alert, it's nothing to do with us. Machines can't really think for themselves or make decisions for themselves. They can only do it based on the data and the algorithms that we give it. So if our data is not qualitative or quantitative enough, then it will not be able to perform what we want it to do. The other thing that we've looked at is machine learning. We have discussed what machine learning is and how it's a subset of AI. We've discussed the process it takes, so it collects data, chooses an algorithm, and makes a prediction. We then talked about what an algorithm is and how it is a set of instructions that a computer or a person could use to follow a task. Example being how to make a cheese sandwich, which you can have 1,000 different steps for. Then we looked at some of the machine learning algorithms that we are going to cover throughout the rest of these sessions, such as decision trees, which is breaking down decisions into smaller and smaller pieces, and KNearest Neighbor algorithms. We are going to be using the KNearest Neighbor algorithm next week, and we are going to use it to determine whether Jack and Rose from the movie Titanic would actually survive on the Titanic using data from the records made. So hopefully that'll be quite interesting to you guys. And I also gave you a link to try out what algorithms are, which is a website you guys can try out. Hopefully you have enjoyed this session. I've enjoyed it as always. It's been really nice to hear from you guys again. And hopefully I will hear from all of you next time. That, unfortunately, is the end of this session. Thank you so much for all of you watching. It's really nice to see you all again. And stay tuned for more machine learning algorithm stuff next week. Thank you, guys.